Hello boys, I Dr. Pradeep Kumar Srivastava welcome to all of you in my water resources engineering class. And today's topic is the runoff and flood frequency analysis. Dear boys, think that which water have been dropped from the cloud to earth, then few water we have kept reserved for our future, and few water has been washed out in the drain, and few after the few time it has joined to the big river, and it has gone in, at the end point sea. So how much water we have reserved? Which water we have stopped in our farmer's field? It's all water said run off. And how we know flood has come? So how flood frequency analysis and what is the watershed management? So about to this topic we will read in this class. Let us start. This is the runoff and flood frequency analysis. Design flood for given location at a stream can be estimated by a number of approaches, including flood frequency statistic and the design storm method. If applied to the same catchment, the two methods often vary quite differently. The aim of this paper, the aim of this topic is to contribute to understanding the reason for the differences. A case study performed for 10 alpine catchments in the Tyrol, Austria, and where the 100-year flood are estimated by a flood frequency statistic and B an event-based runoff model. To identify the source of difference of two methods, the 100-year method are also estimated by and C Monte Carlo. Simulation using a continuous runoff model. The results show that in most catchment, the event-based model give larger flood estimate and then flood frequency statistic. The reason for the difference depend on the catchment characteristic and different rainfall input that we are applied. For catchment with a high storage capacity and the Monte Carlo simulation indicate a step change in the food frequency curve, and when storage there should it exceed it, which is not captured by flood frequency statistic, and flood frequency statistics therefore tend to underestimate the flood in this catchment. For catchment, with a lower storage capacity for significant surface runoff, no slip change occurs. But in three catchments, the design storm usually are larger than those read from IDF intensity, duration, frequency curve, leading to an observe leading to estimation of the design flood. Finally, also the correct representation of flood. Dominating runoff compensate was shown to influence design flood result. Geological information on the catchment was essential for identify the region for the mismatch of the flood estimate. So flood frequency analysis is the technique commonly used to relate the magnitude of the extents runoff a river and flow event to their frequency of occurrence through the use of the parabolic distribution function. Historical record provided essential information to predict the recurrence interval of the hydrological extreme. Such information on highway, such information on high flow event is crucial in many cases. Tight design for flood protection, reservoir design and management, river pollution control, and ecology management. Data observed over an extended period of time at river gauging station are main input of flood frequency analysis. A assumption is made that flood data or space and time independent intentionally disturbed and unfurnished by natural or man-made changes in the hydrological system, RAO and Hammett 2000. The analysis estimates that the resource interval of the extreme event by the extra floating beyond the length of the record. Obviously, the longer the available data and more accurate the estimation are infiltration. So actually hydrological cycle, it means evaporation of the water from surface source like river, lake, ocean, from the surface of soil, plant through transportation. By the process, water is converted into vapor. Condensation. It is the process by which vapor is converted into solid form, cloud, and now delineation in the process are dividing the watershed into discrete land and channel segment to analyze the watershed behavior. And it means drawing to line on a map to identify a watershed boundary, and they typically drawn to topographic map using the information of contour line. Contour line are equal elevation. So any point along the given contour line, the same elevation. Now, interflation. After water reach the ground is interflated into the ground, and surface detention, some part of the water stored in the depression present on the ground. Now, watershed delineation. So, source of data, topo sheet from Survey of India and digital elevation mode, DEM. So, DEM, it is the digital mode or 3D representation of the terrain surface created from the terrain elevation data which can be obtained through a land surveying using auto level, theodolite, total station, GPS, DGPS, etc. And next, remote sensing. That is the aerial photography, lidar, light detection and ranging, and that measure distance by the illuminating a target with the laser and analyzing the reflected light, satellite image, car to DEM. Now, this is the instrument of the land surveying and this is a total station. So, land surveying. What is the land surveying? So, what means of land surveying? Actually, this is the location with X, Y, and Z, where you have given a location and that longitude, latitude, and altitude, where you have provided three stations. So this is the example for this data, land survey, and this is the contour data. This is the contour with 3D digital model, and this is the remote sensing. Contour DEM and 30-meter resolution. And this is the also 3D dimension. And this is the elevation. And this is the elevation. This is the contour data. This is the next contour data. This is the a 3D model. This is a 3D model. This is the runoff. How the location of the runoff. Actually, see this picture. In this picture, these water we have stocked or stored. That is the runoff. So runoff computation. So heavy pace and huge damage taking place in the watershed due to the occurrence of flood. And flood is produced due to heavy rainfall and its estimation is dependent on rainfall intensity, type of soil, shape and size of watershed, and condition of watershed at the time of rainfall, and slope of water and slope of waterway. So runoff computation and method of estimation of the runoff. The empirical formula, envelope curve, and physical indication of past flood, rational method, and parabolic maximum precipitation and rating curve, unit hydrograph method, SSCCN method, and flood frequency analysis. So runoff computation. So this is the empirical formula. And a discharge is equal to Ca to power 3 by 4, where Q is equal to design flood, A is equal to area catchment, and C is equal to Deacon constant, and North Indian plant and North Indian hilly region, and Oriental India, and coastal Andhra and Odisha. Now empirical formula. So Rayaj formula, then Q is equal to Ca to power 2 by 3, where Q is equal to design flood, A is equal to area of catchment in kilometer square, C is equal to Rayaj constant, and area within the 80 kilometer from east coast, 8.8 area within the 80 to 160 kilometer from east coast, 8.5 meter limited area near hills, 10.2. Next, runoff computation in empirical formula. So, English formula. Discharge Q is equal to L 24A under root A plus 104, where Q is equal to design flood and A is equal to area of catchment in km square. It is based on the data of watershed and western sea in Maharashtra. Now runoff component. So major limitation of using empirical formula is a subjective decision about the value C to be adopted. Now envelope curve. So Kanswara and Conroe, after collecting a large amount of the data from River of India and presented two envelope curve in so in figure. This is now physical indication of past flood. Ancient monument situated near a bank of river, always near the mark of record of the past flood. So the flood discharge is obtained from the formula is equal to Q is equal to A into V. It means discharge is equal to area into velocity, where A is area cross section of valley during the dry season, and velocity of low can be calculated from the morning's N, and usually factor of safety about 1.5 huge to the often maximum. Now rational method, it is the most effective in urban area with a drainage area of less than 200 acre, and the method is typically used to be determine the size of a storm, sewers, channel, and other drainage structures. It means discharge is equal to C by A and 3, 6. Where C is equal to runoff coefficient and L is equal to rainfall intensity I and A is equal to area of catchment in km square. Now note rainfall intensity can be found from the intensity, duration, frequency, IDF, HDF, other the representing to the time of convener and at the other period. Runoff coefficient C is equal to type of correction we use to this formula where value of C is this. This is. Now runoff computation in the run rational method. Assumption that drainage basin characteristics are finally homogeneous. The rainfall duration equal to the time of concentration and result of the greatest peak discharge. The time concentration is the time required for runoff to travel from the most distant point of the watershed to the cullet, and time of correction is equal to hydraulic length oblique velocity. Rational method, so time concentration can be found using T is equal to 0.00032 multiplication by L 11 upon 3.0365, where time are generation and maximum length water. Now parabolic maximum precipitation chart. So PMP chart have been prepared by Meteorological Department India for same states such as the Punjab, Haryana, Delhi, Rajasthan, and using following method. So methodological method, statistical study of rainfall data. RMP, August rainfall plus K0, and where frequency factor depend on the statistical distribution cell and no number of year record, and the return method. So Q is equal to standard deviation. This is the diagram. This is the rating curve. Now, unit hydrograph method. It is the linear model of the catchment which is used to find out the volume or direct surface runoff. It means DSR, direct surface runoff, due to 1 centimeter of rainfall excesses and rainfall come to the catchment, producing 2 centimeter of excess rainfall. The ordinates of the DSR will be twice at the such ordinate and volume of DSR willing the volume of your photograph. Assumption: the rainfall of this facility inform and with the specified name. This is the unit hydrograph method. This is the peak. Now, SSCN method. So the curve number method was developed by the USDA National Resources Conservation Services, such as the formerly called the Soil Conservation Service for SCS. So the serve number is because the curve number is based on the area is hydrological soil and the group land use treatment is the hydrological condition. Now SCS minus CN is equal to actually a formula I had. So this formula where P is equal to rainfall and S potential maximum and potential maximum filtration after runoff magnesium. Now hydrologic. HCC group, a low runoff potential soil with sign anti-filtration rate 7 when the thoroughly wetted final infiltration rate greater than 0.3 inches per hour. So HSC group B, soil with moderate infiltration rate with the thoroughly wetted and finely infiltrated rate 0.15 to 0.30 T. HSG group, the soil with the slow infiltration rule and when the slowly wetted final infiltration rate 0.05 to 0.15 inch per hour and HSC group. So high runoff potential soil with very slow infiltration and so thoroughly the weighted final filtration rate less than 0.05 inch per hour. This is the chart. Now, high run potential. The soil with very slow infiltration rate, so when thoroughly wetted, and final infiltration rate less than 0.05 inches per hour. And this is the standard chart. This is the also chart, and we test it. Now flood frequency analysis test. Estimation of design flood. So flood frequency analysis. Return flood. A return period, also known as the recurrence interval committed, respect internal is one estimate of the likelihood of flow of the river discharge and flow to occur. For example, a 10-year flood. For example, a 10-year flood, if 1 by 10 or 0.1 10% chance is being exceeded in any 1 year, or this does not mean that is the flood with the such a instead, and it means that it is a given year and there is a 0% chance what it will be happen recognized often the last similar event was. Now return period and its statistical measurement typically based on the historical data and basically used for the risk analysis, and then so device to whenever a project to be allowed to go forward and zero of a certain risk of the design structure and watershed are referred with a certain return period. So what is the method? Actually, Valbull method, Gumbel method, and Locke-Pearson method. So Valbull method, what is? Probability theory and statistic, it is a continuous probability distribution. The most economy used method and I and value are destroyed uniformly between 0 and 100%. And probability there are most be n plus 1 interval and n table the data point and 2 of the site. Probability p is equal to m upon n plus 1. And this is the example. Consider the where y reduce very the 1.282 q minus q. This is the formula. And again, Gumbel extreme value distribution method is showing this. And this is the rainfall frequency analysis. So Gumbel extreme value distribution method by distribution method. And rainfall frequency analysis, Gumbel's extreme value distribution method by the chart. Now, log Pearson type third distribution method. So, this is the year-wise log Pearson type third distribution method, and it is had decided in 1930. And log Pearson type third distribution method, after the putting the value, this result has come. So, precipitation in the form of the rain, snow, and steel, drizzle, etc. What is the interception? When precipitation occurs intercepted by vegetation, so the part do not contribute to the surface water. Water which flow on the ground or surface and joint channel is called surface runoff. So groundwater flow of the interflow and the water which infiltrated into the ground join the stream on the later stage is called interflow. Now, form of precipitation. It first rain. It is the main form of the precipitation in India when the size of the top and size the drop is larger than 0.5 mm. It is called rainfall. The rainfall is classified into light rain and its intensity is traced to 2.5 mm. So moderate rain, its intensity is 2.5 mm to 7.5 mm, and heavy rain above 7.5 mm. So form of preparation. So snow is the made of one of the more teeny lies and crystal that come together to form the unique snap on the snow hat. And drizzle is a light liquid or participation consisting of liquid water drop similar than the doge or rain, generally similar than 0.5 diameter and having intensity less than 1 meter. Now form of precipitation. So rain is the main form of precipitation in India when the size of the drop is 0.5 mm is called rainfall. And the rainfall is classified into light rain, its intensity 2.5 mm per hour, and moderate rain, its intensity 2.5 mm to 7.5 mm per hour, and heavy rain above the 7.5 mm per hour. So form of precipitation. So is the made up one of the more teeny ice crystal and that sum together to form unique shape of the snowflake. So drizzle is a light liquid and precipitation consisting of the liquid water drop. So similar than those of the rain, generally similar or 0.5 mm diameter and having intensity less than 1 mm per hour. Now sleet, a mixture of rained snow, and when the temperature of the atmosphere and that near to ground is 0 degree, and since then precipitation will be mixture of the rain and snow and dew, so formed by the concentration on the ground during the night, and when the surface has been cooled by the outgoing location and addition. So, dear boy, you have read the related topic, and I want to ask you some MCQ on this related topic. Now, a multi-purpose reservoir is the one which designed for one purpose and but in services. So, which is correct answer? There is four answer looking on your screen. So correct answer is B, planned and constructed to serve various purposes. And next, a rain gauge should be water. A rain gauge should be preferably be fixed. So which are correct answer? So dear boy, correct answer is C, and in an open space. And next, a rippling grayon is arranged. So in which are correct answer? Correct answer is A, pointing upstream. So next question, a hydroelectric scheme operating under a head of 80-meter well be classified as, so how you will classified that? Which is the correct answer? Yes, correct answer is C, high head scheme. Now a land known as the waterlogged. So which is the correct answer? Correct answer is C, capillary fringe reach the root zone of the plant. And next question is a hydrograph is a graphical representation of, and which is the correct answer? Correct answer is the A, rainfall intensity and time. Now, next question, a 70% index of the wetness means Which are correct answer? Yes, correct answer is B, and that is rain deficiency of 30%. Now a deep well is always deeper than shallow well. Which is correct answer? Correct answer is B, has more discharge than a shallow well. And the next question, a current meter is used to measure the, which are correct answer? Correct answer is A, velocity of flow of water. And last question, a divide wall is provided so at right angle to the axis of here. This is the correct answer. This is answer A. So this is the references which have taken from the material for this course, and this is the references your books, and this is the web references. And thank you for taking interest in my class. You are all welcome in my next class. That will be tomorrow.